Hello and welcome to section 8.6, which covers the law of cosines. The law of cosines states that it relates the cosine of each angle to the side lengths of the triangle. And it's a fairly long equation, and it changes a little bit depending which side is missing. And so I have all three variations written here. A squared equals b squared plus c squared minus 2bc times the cosine of a. And then b squared equals a squared plus c squared minus 2ac cosine of b. And c squared equals a squared plus b squared minus 2ac times the cosine of c. And you can see it goes along with this picture right here. Okay, so angle A, angle B, angle C, and then side A, side B, and side C. And so we're going to use that information to go ahead and solve one of these problems. So this one says find mn to the nearest tenth. The first thing I'm going to do, just because I want to relate it back to this triangle and to these formulas, you can see that C is your longest side, and so I'm just going to put C in there just so I kind of keep it straight in my mind. This would be B and this would be A, according to this picture. Okay, so I'm going to keep that in mind while I'm going through here. And so if that is side C, then I'm going to use this little formula. Not little, I guess, but so c squared equals a squared plus b squared minus 2ac, and then at the end times cosine c. Okay, so I'm just going to plug stuff in here. I don't know my c squared. Okay, so c squared equals, my a is 29 squared, my b is 48 squared, minus 2 times a, which is 29, times my 48, should be 2ab. I accidentally put c there. Cosine c. So I need this times 48 times cosine c, which I'm running out of room. Try to write smaller. So I need to go do some work. 48 squared is 2,304. And 29 squared, 841, minus 2 times 48 times 29 is 2784. And then I still have times cosine of c, which is 104 in this case. Now I can do a little more work as I'm going through here. So I would have c squared equals, and I should have this 841 first, I guess, since I had a first right here, plus 2304 plus, I went ahead and did this part on the calculator, and I got 673.5. Now I can just go ahead and add all those together, and that is 3818.5. To get rid of the c squared, I do square root, and therefore c equals 61.8 degrees for my answer. Okay. Up here, it should have been a b in my formula, so I had to change it right here. You use the two sides that you're not using. So since I was doing C, I used the other two sides. Another variation of this same type of thing, in triangle TUV, find the measure of angle T to the nearest tenth of a degree. So now I don't know any of the angles on this one. And again, I think I'm going to plug in my sides just to remind myself. That would be C, this would be A, this would be B, according to that picture up above, just so I can kind of keep that in mind. And hang on a second. So since I'm trying to find c again, I'm going to use that same formula that I just used. So c squared equals a squared plus b squared minus 2ab times cosine c. Or in this case, it would be t. So c squared equals, and actually they give us the c, so I could plug that in. So 7.1 squared equals my 4.4 squared plus 6.7 squared minus 2 times 6.7 times 4.4 times cosine c. Go ahead and work this out. You get 50.41 equals 19.36 plus 44.89. Where am I getting these? I'm squaring these numbers. Minus 2 times 6.7 times 4.4 is 58.96. And then I still have to do times cosine c on the end. So I can go ahead and subtract this and this, move it to the other side. So I'm going to go ahead and do that all at once. So subtract this and this. Gives me a negative 13.84 equals, I have a negative 58.96 times cosine c still over there. And when I go ahead and divide by 58.96, I end up with 0.23 equals cosine t, or c in this case. And to be able to solve that, when I plug it in, I have to go cosine negative 1.23. And then when I plug that into my calculator, it will come up with an answer of 76.4 degrees. And I realize this seems rather involved, maybe pretty complicated. We're going to go through and do several examples together. Just bring this knowledge with you, and we'll work with it the next time I see you. Have a good night.